Okay. We talked also about the ABC analysis, and we gave one example of ABC analysis. This was before the break. Cycle counting. We said we can use ABC analysis with cycle counting uh, to save time. So, and we had one example where we have these 5,000 items, and we have to like know the value for each item, and then we itemize them, and then we start with the highest value. Okay. Oh, I need to go back. And then we calculate how many we need to count every day for each one. And then we move to the types of demand and models. And we talked about inventory models. These are some definitions here: holding cost, ordering cost, setup cost. The holding cost is the cost of holding or carrying the inventory, and the ordering cost is the cost of placing an order, and the setup cost is the cost of preparing the order. Okay. We talked about also the holding costs. They are like percent of the inventory value. It depends on the type of inventory we are holding. Can you please mute yourself? Oh, let me mute everybody. Mute all. And then we started talking about the inventory models for independent demand, basic economic order quantity, which we call EOQ, economic order quantity model. So we said we will cover all these. We started with the EOQ, and then we stopped here. We said here, this is the time with inventory. This is the inventory. So when we order the inventory, let's say we are selling like phones, for example. At this time, we order 100 phones. So we have 100 phones here, right? And then we start selling. So the number will go down until we reach zero. That means at this time, we have this much inventory. Then we order again, selling, order, selling. So this is the what we call the inventory usage over time. So inventory level with time. And then we said, okay, if we put all these costs together in one figure, so this is the holding cost, this is the setup cost, and we put them together, and the total cost can be drawn with this. So this is the lowest point here. This is the lowest cost. So our goal is to lower the cost. So this will be the quantity that we should order here to get the with the lowest cost. This is the cost, right? So look, here the cost is high. Here the cost is high. Here is the lowest cost that you can get. So this is the quantity. To do that, By minimizing the sum of setup or ordering costs, whole total costs are minimized. Optimal order size. So the goal is to find the optimal size. So let's say we are selling seller phones. We want to know how many phones do I need to order every week or every month or every 2 weeks or every 2 days. So that's the goal. Because as we mentioned before, there is a risk for holding uh, inventory. We said this will cost us lots of money and we need space and it is like it's risky. So we need to know, and at the same time we need to uh, satisfy our customer needs. Okay, so this is called the optimal order quantity. We are interested in q from quantity. Q star is the optimal. So when we say calculate q star is the optimal order, okay, quantity. So yeah, I think we covered all that, and then we stopped here. So we said based on that graph, the holding cost, which is order quantity, that times, which is the average. This is the average. You remember that graph? We said Q over 2 is the average. So if your Q is 100, so Q over 2 is 100 over 2. So your average uh, inventory is 50. So on average, you have 50 phones in your store, for example, times how much it costs you per year. Let's say it costs you per phone to hold a phone, this including insurance, rent, utility bills, everything. Let's say $50. So if your average 50 times 50 is $2,500, this is the annual holding cost for a phone or for a car or whatever, which is Q over 2 times H. Okay, this is the holding cost. So based on what we saw on that chart, you remember when we said when they are equal, so this is the optimal quantity, Q star, so they are equal. So we equalize them, and then we rearrange the formula. So your D over Q times S is equal to Q over 2 times H. This is the setup cost. This is the holding cost. They are equal. Okay, so you take this Q here, it will be Q square. Okay, and then you divide by 2ds. This will be a what? And you take the square root. This will be Q star is equal to 2ds over H. This is the optimal number of pieces per order. Okay, that's the formula that we are looking for to solve for the optimal number. What's the optimal number of phones that you need to order every time? It's equal to 2ds, where D is the annual demand. Okay, D is the annual demand. I should know the annual demand. I should know the setup cost. I should know the holding cost. If I know all these three, I can calculate the optimal number of pieces per order, which is also called EOQ. Let's see example here. Sharp Inc, a company that markets painless hypodermic needles to hospitals, would like to reduce the inventory cost by determining the optimal number of these needles to obtain per order. The annual demand D is 1,000. The setup cost is $10. The holding cost, the H, is $0.5. So we need to calculate Q star. We said Q star is equal to 2ds over H, right? Let's do it here. So D is 1,000 units. S is 10 per order. H is the H is 0.5 per unit per year. So Q star is 2ds over H. 2 times 1,000, which is the D, right? Times S is 10 divided by 0.5. The square root of 40,000 is 200 units. Okay? Any questions?
No question.
So now, determine expected number of orders. If you know Q star and you know the order, the demand, you can know how many times, right? You can order every time. So let's say the demand for year, when we say capital D, this is yearly or annual demand. It's called annual demand, is 1,000, okay? And every time you order 200 units. How many times you need to order every year? It is 1,000 divided by 200. 10 over 2 is 5. Okay? Questions? Okay, this stuff we will do from now to the end of the semester, and you know it's very important. This is the basic calculations that we are doing, and most of the final questions will be similar to this. So if you have a question, just ask. You can use the chat box to ask the questions. Just give me 1 second. Okay, so now we can calculate the Q star. We can calculate the number of n, okay? Determine optimal time between orders. Of course, we said we have 5 orders. Number of working days per year is 250. So you should know this. If it is not given, just expect, assume that it is 250. So 250 divided by 5. So 50 days between orders. So on day 0, we order. And then after 50 days, on day 50, we place another order. And day 100, we place another until the end of the year. You have 5 orders. Okay, the total cost. The total annual cost is equal to the setup cost plus the holding cost, which is originally TC. We call it TC. TC is the total cost. D over Q, we know D, it's 1,000. The Q is 200 here, it's given. Times the setup cost plus 200 over 2 times the holding cost. Okay, so 5 times 10 plus 100 times 0.5. So this is equal to 100. If the product cost is not included, so sometimes it is included. Okay. This is another example here, management in the sharp INC example, underestimate total annual by 50%. Say the demand actually was 1,500 needles rather than 1,000 while using the same Q. How will be the annual inventory cost be impacted? They made a mistake. So let's calculate for both and see. So determine the optimal number of needles to order 1,000 units. So they used 1,500. So the total cost, if they used 1,500, is 125, but which is D over Q times S plus Q over 2 times H. Okay, so 1,500 over 200 times 10 plus 200 divided by 2 times 0.5. So it's 125. If you are using the new Q star 1,500 divided by Q star, which is here 244 times 10, so it is 122. Okay, so there is a difference between the two orders. EOQ answers how much questions, so it is called reorder point. When should I reorder? When do I need to reorder? So we said you are running a store and you are selling phones, okay? So if you are selling phones, you need to know when you reorder. So let's say Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So when do I order? How many phones should I have to place the order? Okay, so the reorder point is the demand per day times the lead time for a new order in days. Demand times L. Okay. The other thing, the daily demand. Don't be confused between the daily demand, which is the small letter D, with the annual. This is the annual demand, capital D. Okay, to calculate the daily demand. So you divide, you remember we just said, we have 1,000 needles and we have 250 working days. So 100 divided by 5 is how much? 4, for example. This is our daily demand. Let's see how we calculate the reorder point. So look, this is the inventory level. This is where you ordered Q star. Okay, so here the lead time. So this is the lead time, for example, time in days. Let's look at this example here. Okay. An Apple store has demand D for 8,000 phones per year. The firm operates 250. See, you are given the annual demand. You should be given the annual demand. Uh, and the operating days. They operate 250 days a year. On average, delivery of an order takes 3 working days. This is the lead time. Okay, this is the lead time. So when you order something from Amazon, if you order it today, probably they say, oh, you will receive it within 3 days. That means you will receive it within 3 days. Okay. But has been known to take as long as 4 days. Sometimes they say it take 4 days. Okay. The store wants to calculate the reorder point without a safety stock and then with 1 day safety stock. The store wants to calculate the reorder point without a safety stock and then with 1 day safety stock. Okay, let's see. First, compute the daily demand and then apply equation 12.6. We call it the reorder point. So we said the daily demand is the annual demand divided by how many days, working days. So 8,000 divided by 250. It's 32 units. This is the demand, daily demand. Okay? Any questions? Okay. So now we have 32 units. Now we can calculate the reorder point. Let me remove these scratches here. The reorder point. So we have 32 units time the lead time, 96 units. So they said sometimes it takes 3 days, sometimes it takes 4 days. So if it takes 3 days, when I have 96 phones in my store, I need to place the order. If it takes 4 days, when I have 128 days units, I need to place the order. That's the reorder point. It's a point. A point means the level of inventory when you order. That's the meaning of this point. How many phones you have in your store? Because you need to satisfy your customer. How many cars you have? How many, whatever you sell, okay? Items you have in the store, when to reorder, okay? That's the reorder point. So here we covered enough today. I will do what? 18, 25. If they fix the room tomorrow, our room, I will let you know. I will contact them today now after the class and see. If I don't send you an email and ask you to come to the room, just we will do a Zoom meeting. Okay, and I will try to send you a link, but I use the same link for all my meetings for Thursday, okay? I want to make sure that they are fixing the room before we go there, because today we wasted 20 minutes. I don't want to waste another class. Okay, so what we covered today, the first part of chapter 12, make sure you need to know how to calculate the Q star, how to calculate the number of orders, the time between orders, the setup time, okay, the holding cost, the setup cost. There is also later we will cover the setup time, but not in this chapter. The setup cost, the setup, the holding cost, and the total cost, and the reorder point. Okay. There is an assignment. Let me see. There is an assignment and a quiz for this chapter. Internet is slow. Right. Yeah. I will open this. I don't think I did. For chapter 12. Chapter 12. Yeah. I will open this assignment. This is related to this chapter. Even we will finish this probably this week, but I'll give you more time to study. And also the quiz. October. Okay, that's enough for today. We'll see you on Thursday. As I said, I will let you know if we can fix. I will try to go tomorrow during my 3 hours to fix this, but I will send them an email. I will let them know. I will go now, talk to them. Okay? I will post the recording for this meeting. Okay? And try to go over. You can solve some of the questions from this homework. But don't try the quiz. The quiz, try it when we finish the whole chapter, because we have not covered everything. Okay? Okay. See you on Thursday, unless you have questions. No questions? Okay. Thank you.
Thank you.
Thank you.